It is an absolute shocker what information is just readily available on the network if we simply know where to look. And one of those places is looking for NetBIOS related information. The network basic input-output system, NetBIOS, has been around for decades, and it never scaled really well, but it's still alive in something called NetBIOS over TCP/IP. And one of the great things about NetBIOS is that there's a lot of information that we can discover, including computer names, shares that are available on the network, and services that are all being advertised or promoted as part of NetBIOS. And what I thought would be fun to do is let's go ahead and use the command line interface and some graphical user interface tools to enumerate some network devices using NetBIOS. So in our lab topology, let's fire up some virtual machines. We'll fire up Windows 8, Windows 10, Windows 2012 server, and we'll also launch our Kali box to demonstrate how we can glean and gather NetBIOS related information, whether we're sitting at a Windows computer itself or whether we're sitting at a non-Windows computer. In this example, a Kali Linux box. So in our lab environment, let's go ahead and launch some of our virtual machines. There's Windows 8.1, we'll power that on. We'll power on Windows 10, Windows Server 2012, and let's also power on our Kali Linux box. And starting off with our Kali Linux box, let's go ahead and log in as root, and we'll put in the default password of TOOR. I'm also going to go ahead and maximize this screen as well. Now on a Linux box, we don't have the native tools like NBT stat, this NetBIOS over TCP statistics that we would have on a Windows platform, but we have other tools. For example, we have Nmap and ZenMap. So let's go ahead and launch ZenMap. Now to get there, we could just go to a command shell and simply type in ZenMap, or we could go to Applications and go down to Information Gathering, and then down through the menu system, go to ZenMap. We'll maximize that screen as well. And let's do a scan of 192.168.1.1. And I'm going to use the option of a -O. And that O is going to tell Nmap to, if it can, extract the operating system that's running on that platform. And we'll press enter to launch that scan. So it did a port scan and it found various ports open, including NetBIOS SSN, which it shows as TCP 139. And if we saw UDP port 137 or TCP 138 or TCP 139, those are all related to NetBIOS. And here, 139 specifically is the NetBIOS session service. This scan also identified that it's very likely some flavor of Linux that's currently running on that host. Now the benefit of knowing that 139 is open is that we now know that this device at .1 is running some type of NetBIOS service. So let's minimize this just for a moment by grabbing the top edge, getting the ribbon, and then exiting full screen mode. And let's go over to our Windows 10 machine and make it full screen. Now here on Windows 10, we can simply click on the Windows icon, type in CMD, and bring up a command prompt. And one of the basic tools that we can leverage right here on Windows platform is a command called NBTstat. If we type in NBTstat and press enter, that's going to give us all the options that would follow NBTstat. And there's a couple that I'd like to bring your attention to. One is NBTstat-a. If we do an NBTstat space -a, it's going to give us the NetBIOS over TCP information regarding that host. If we use a capital -A instead, we can put in the IP address of that host instead of the NetBIOS name. Another one that I love is -C, which is to show us the cache. And that's a very quick way to see the other NetBIOS machines on the network, including their IP addresses. So from the scan we did over on our Kali Linux box, we know that 192.168.1.1 is running some NetBIOS services, because it had TCP port 139 open. So what we could do here is do an NBTstat space -A. Actually, we should do a capital A and actually put in the IP address of 192.168.1.1 and press enter. And that's come back with a list of names here on the left. And next to it has some codes. Now the MAC, the MAC address, I can darn well guarantee you, is not all zeros. So perhaps this device at .1, which does have some NetBIOS services running, isn't fully compliant with Microsoft's NetBIOS over TCP/IP. Because normally that would come back as well with the actual MAC address of that device that we just queried. And regarding these codes right here, let's bring up a couple of wiki articles regarding NetBIOS codes. So as we bring those in, I've got two articles up. They're both on Wikipedia. One is NetBIOS over TCP/IP, and the other is just NetBIOS. And if we scroll down through these articles, they have a lot of great information, including the history of NetBIOS. Here we have a section called NetBIOS suffixes. And it indicates that the 16th character of a NetBIOS name indicates the service type. So a 00 would be the workstation name, 3 would be Windows Messenger Service, 20 would be a file service. And then we have a couple here referring to browser services. Now, a long, long time ago, in a galaxy far away, we didn't have Windows Internet Name Service and DNS that may have been running in everybody's network. And networks that were relying solely on NetBIOS were using NetBIOS and these browser services for the resolution of NetBIOS names to their corresponding IP addresses. And for group names, the codes changed a little bit. So if we take this information and we scroll over just a little bit, we can identify some of these. Here's a 1D, which would be a master browser. A 1E would be browser service elections, and a group of 00 would be the actual workgroup or domain name. The 03 represents Windows Messenger Service, and 20 represents file services. So we can learn quite a bit just by what NetBIOS information is being offered by the hosts on the network. Now, to take it a step further, we could also use commands like netuse. Now, for the net command, if we do a net and press enter, it's going to give us a whole list of options that we can use with the net command. So we have netuse and netview, along with many others. So if we wanted to view, for example, the shares on the device at 192.168.1.1, we could type in net space view and then // the IP address of that device at 192.168.1.1 and press enter. And what that's showing us is that we have a share called My Passport Disk that is available over the network. There's also graphical user interface tools as well that we could use for NetBIOS enumeration. For example, if we open up a browser and we type in NetBIOS enumeration, and then I'm going to put in site:/sourceforge.net and press enter. This is the one I'm looking for right there. It's the NetBIOS emulator. If we select that, and then we scroll down just a little bit here so we can download the Win32 binary for it, we could download that. And then once it's downloaded, we could extract it and run it. And since we have it downloaded, I'll go ahead and right click. We'll look at that in the folder. We'll extract it right there. And then we'll go ahead and launch it, the NetBIOS enumerator. And although it's from an unknown publisher, I am on a test machine. It's a virtualized machine in my lab environment. So I'm going to go ahead and run it. We'll expand that to be full screen. And then we can scan a range of IP addresses. So we have some scanning going on, as well as the NetBIOS enumeration from those devices. Now in the settings, we can also specify, as far as the port scan, what ports do we want to scan for. And regarding the connection, if we've compromised a domain username and password, and we want to try to log on with that, we can put that in here as well as part of our scan. And that will give us even more information about those devices. Now, as an attacker, we don't yet have that information, so we won't be able to log in as a user, but that's an example of how we could set that up in the tool if we wanted to. So I'm going to click on cancel. I'm going to put in the range of 192.168.1.1 all the way through 192.168.1.254, which is the usable IP address space on my 192.168.1 network, and I'll click on scan. And that'll take just a few minutes to go ahead and run through, and as a result, I can have a nice, easy way of looking at the NetBIOS related information it returns to me about those devices. So it found the 1.1. We can expand that while the scan continues. Under NetBIOS names, if we expand that, this represents the same type of information that we viewed from the command line with nbtstat. Except instead of giving us the codes, it actually told us what the actual codes represented. And through the magic of editing, it's now completed the entire scan. So let me go ahead and open up 2012. There's our 2012 server. Here's our Windows 10 machine. And one thing I noticed that's happened to me a couple times is my Windows 10 machine continues to automatically put back on the Windows firewall. So if you've turned off the Windows firewall on Windows 10, and later, let's say the next day or something, you're working with it, and it's not responding like you think it should, you may want to go back and just verify that Windows firewall is still turned off on any of your lab devices that stop cooperating, because that's very likely the case, at least for Windows 10. So if we minimize this, went back to the command line for a moment on this Windows 10 computer, and we typed in nbtstat --c and pressed enter, because this Windows 10 machine was actively going out and communicating with these other devices, now at the C, the -C for cached information, is showing us the names and also the IP addresses of those devices. And that list is now populated again because we're going out actively and it's been probing all those devices, asking them for their details. While we're here at the command line, another really cool option is netview space, and we'll do a /. I'm going to put in domain, : and we can specify our domain name. Now, in our case, I don't have a Windows domain set up. We're using the group called workgroup. So I can put that there instead and press enter. And all of these devices are associated with the group called workgroup. And we have a little tip here regarding the type of file services that may be available over on this device. We could do an nbtstat -a kb, press enter, And that indeed is the same device we were looking at earlier, 192.168.1.1 with those services running. So another really cool thing about Windows, it makes it very easy to use a graphical user interface, the one that's built into Windows. So for example, if we bring up Explorer, referring to File Explorer, and I click on Network here, it says here that network discovery and file sharing are turned off. Click to change. So I'm going to click on that and select Turn on Network Discovery and File Sharing. And I'm going to say yes. Now this Windows 10 machine is showing me all those devices that have some type of NetBIOS over TCP/IP services running, which we could go ahead and drill into. We also have 2 devices that are showing up as potential media devices. So if we selected KB and double-clicked on it, there's a share called My Passport. We saw that earlier from the command line. If we double-click on that, it would appear that there is no security set up regarding this share. So if we go to Backups, for example, it's showing us all the files here. And this happens to be a backup drive that I actually use in my home network that is absolutely not secure. And as an attacker, this would be a very easy find. And all of this enumeration that's being done is courtesy of NetBIOS services on our networks. In this nugget, we've taken a look at what can be collected and extracted with enumeration of NetBIOS information. I'm glad you joined me for this nugget. I hope this has been informative for you, and I'd like to thank you for viewing.